June 2025. In the span of just 4 nights, a single telescope alert flagged a blazing dot of light streaking through our solar system. It was moving at nearly 152,000 miles per hour, faster than any known asteroid, and its path was unmistakably interstellar. NASA quickly confirmed the signal. This was 3I Atlas, only the third object ever witnessed from beyond our sun. But what followed broke every pattern we knew. Its brightness was far too high for its size. Its path, traced back toward the dense heart of our galaxy, showed ghostly deviations that no ordinary comet could explain. Some scientists now argue it's more than just rock and ice. Could it be a test, a warning, or maybe even a message? So, what final signal did 3I Atlas really send? And why is the world on edge right now? It all began with the Atlas night crew in Chile, their eyes glued to the data stream, waiting for anything out of the ordinary. On June 25, 2025, the automated alert system flagged a faint, fast-moving point of light. It didn't match any known asteroid or comet in the catalog. The timestamp read 3:17 UTC. Within minutes, the system ranked it as a top priority, triggering a cascade of follow-up checks. For the next 4 nights, every clear hour was critical. Each pass of the telescope added a new position to the growing track. By June 29th, the object's motion was undeniable. It was slicing through the sky at a pace that made even the most seasoned observers hold their breath. The window for this discovery was razor-thin. The star fields near the galactic center nearly hid its trail. It was only by combining Atlas' rapid response system with archived images from another observatory that the team realized the object had actually been visible as early as June 14th. Still, that official detection window, from June 25th to the 29th, was all that separated a historic find from a completely missed opportunity. Every hour, the object gained distance, its path pulling it away from the inner solar system. Slack channels and late-night calls buzzed with excitement as the Minor Planet Center received the first alert. NASA's confirmation arrived less than a day later. For the Atlas night shift, the incredible realization began to set in. They had just caught the third interstellar visitor ever seen, and the clock was already ticking. Orbital dynamicists at the Minor Planet Center began crunching the numbers as soon as the data landed. The trajectory wasn't just unusual. It was mathematically impossible for any object bound to our sun. The path traced out by 3I Atlas formed an open hyperbolic curve with an eccentricity far above one. In plain terms, it's moving too fast, over 152,000 miles per hour, for our sun's gravity to ever pull it back. This is what astronomers call hyperbolic excess velocity, a speed so great that even as the sun tries to tug it inward, the object simply shrugs off that pull and keeps going. The numbers pointed back toward the constellation Sagittarius, near the dense heart of the Milky Way. That direction isn't random. It hints at an origin somewhere deep in the inner galaxy, far beyond the scattered disk of icy bodies or even the distant Oort cloud that surrounds our own solar system. The object's inbound vector and velocity rule out any scenario where it could have been flung out from our solar system. No known planet or previously cataloged object could have given it this kind of boost. Astrometry teams ran repeated orbit solutions, and each one confirmed the same story. This object's speed and angle mean it's not just visiting. It's passing through, never to return. The last 2 interstellar objects, ʻOumuamua and Borisov, showed similar hyperbolic paths, but 3I Atlas stands out for its sheer velocity and the incredible precision with which its orbit can be traced. Every new data point just tightens the case. This is an interstellar traveler, a messenger from a place we can only imagine. Meanwhile, photometry teams at the Vera Rubin Observatory worked through the night, measuring every photon of light pouring in from 3I Atlas. The numbers just refused to add up. For an object with a nucleus just over 11 kilometers across, its brightness was completely off the charts. Even before the object's closest approach to the sun, its coma, the fuzzy cloud of dust and gas around it, stretched nearly 24,000 kilometers wide. A cloud like that should have dimmed as it expanded. Instead, 3i Atlas shone with a crisp, almost metallic gleam. Albedo, the technical term for reflectivity, became the word of the hour. Most comets in our solar system reflect just a few percent of the sunlight that hits them, making them darker than charcoal. This one bounced back far more, putting it in the company of fresh ice fields or even polished metal, not dusty rock. The data, cross-checked with other telescopes, confirmed its outlier status. The surface appeared so bright that some scientists wondered if they were seeing a hollow shell or perhaps a crust layered with unfamiliar ices. Others pointed to the possibility of a highly porous structure, with sunlight scattering off countless tiny surfaces. But no natural comet or asteroid in our archives matched this exact signature. The nucleus was too large for the level of brightness, and the coma was too uniform for a typical outgassing event. Each new frame only deepened the puzzle. If the surface was truly this reflective, it would force us to rethink how interstellar objects survive the journey between stars. The only way forward was to get a closer look, something only the James Webb Space Telescope could provide. The James Webb Space Telescope's observation window opened just as 3i Atlas cleared the sun's glare, giving astronomers their first real chance to probe its true nature. The mid-infrared instrument, or MIRI, mapped the object's thermal emission across a full rotation. Instead of wild temperature swings or hotspots, which would be signs of jets or vents, the data showed a stable, almost uniform glow. The heat pattern fit a body spinning with clockwork regularity, not a lopsided chunk of ice tumbling through space. Every 6.2 hours, the light curve repeated itself perfectly. The principal investigator described the spin as uncannily steady for something of this size. Next, Webb's near-infrared spectrograph scanned for traces of volatile gases. The spectra revealed a coma dominated by carbon dioxide, but the signal was diffuse. There were no concentrated plumes, no sudden surges of gas. The nucleus itself shone through with that crisp, metal-bright reflection, echoing the ground-based suspicions of an unusually smooth or possibly even faceted surface. Yet, even with this incredible brightness, there was no evidence of outgassing strong enough to actually nudge its orbit. Precision astrometry became the final crucial check. Over 2 months, Webb and ground telescopes tracked 3i Atlas's position to within milliseconds of accuracy. The result? Any non-gravitational acceleration, whether from jets, radiation pressure, or something more exotic, was smaller than 1/10,000,000th of a meter per second squared. In practical terms, the object moved as if gravity alone was guiding it. There was no measurable drift, no unexplained push. As one lead scientist summarized, if there's an engine on board, it's quieter than anything we've ever seen. This brings us to Avi Loeb's famous checklist for artificial origin, which reads like a forensic roadmap. It looks for 4 key signs: unexplained acceleration, extreme reflectivity, a lack of outgassing, and a shape or spin that defies natural patterns. Let's map our observations of 3i Atlas onto this grid. First, non-gravitational acceleration. We found none. The James Webb Space Telescope set an upper limit tighter than for any previous interstellar visitor. Second, reflectivity. It's high, but not entirely without some natural, albeit rare, precedent. Third, outgassing. It's present, though very muted and diffuse. And fourth, its spin. It's regular and stable, not erratic or suggestive of engineer control. Each of these criteria demands precision data. But in the world of astronomy, raw data sometimes lands behind short embargoes, fueling debate and speculation. Officially, most data releases follow standard review cycles that take days, not months. But in a case this rare, every hour of delay draws intense scrutiny. The very process designed for scientific rigor can look like secrecy when the entire world is watching. So now we have 3 interstellar visitors and 3 completely different stories. ʻOumuamua, the first, raced through with no tail and a shape that defied every known category thin, elongated and accelerating for reasons no one could definitively prove. Borisov, the second, arrived looking like a classic comet, venting gas and dust just as theory predicted, but moving faster and burning brighter than anything from our own cosmic backyard. Now, 3i Atlas blurs the lines. It carries a broad coma like a comet, yet its nucleus shines with a brightness and symmetry that hint at something new. Astronomers are starting to call it a hybrid, neither a typical comet nor an asteroid, but a sign that the galaxy's inventory of objects is far broader than our textbooks allow. Each new encounter pushes the boundaries of our knowledge, raising the stakes for how we search and how we interpret what we find. The next radar pass, scheduled for its closest approach to the Sun in late October, could reveal structures or movements that have been missed so far. Until then, the world watches, waiting to see if this visitor will rewrite the rules once again. As of this moment, the object's true nature remains unresolved. What is clear is that each new interstellar visitor tests the absolute limits of our detection and analysis capabilities. For now, 3i Atlas stands as both a profound scientific puzzle and a powerful reminder that the search for answers relies on open data, global collaboration, and keeping our minds open to the extraordinary. Thanks for joining us on this deep dive. What do you think 3i Atlas is? Let us know in the comments below. And if you enjoy exploring the biggest mysteries of the cosmos, don't forget to like this video and subscribe for more. We'll see you next time.